Let us do this question. In this it says, charge is distributed within a sphere of radius capital R with a change in volume charge density rho r is equals to a by r square into e to the power of minus 2r by a, where capital A and small a are constants. If the q is the total charge of this charge distribution, what is the radius r? So here, as the charge is present inside, it is nothing but a solid non-conducting sphere which we are talking about. Solid non-conducting sphere which we are talking about. And this. So the charges are present inside the sphere. Charges will also be present in this part. So for a solid sphere, the element that we are going to cut is a small thin spherical shell. So we are bothered about this part, whatever is the charge that is spread over in this thickness. In this thickness only we are bothered about. So this thickness, the charge is spread. If I integrate this entire thing, then I'm going to get the charge that is present over the entire solid surface. So this is what we'll cut and we'll bring it out and we will integrate it. So what is the charge distribution? Charge is distributed in the volume. So charge is equals to rho into volume. Volume of what? Volume of this spherical shell. That too not the inside part. Only this pink color part, whatever is there, volume of that part. In that only this charge is spread. So charge is equals to rho into 4 pi r square, which is area of that hollow sphere, and into we have to do thickness of it. That is how we are going to find volume. We are going to find volume. 4 pi r square into dr is going to give us volume of this part. Only this part. We are not bothered about the inside part. It is only about this part. Okay. That is 4 pi r square into dr. So now we have got charge and also volume. So now charge is equals to integration of rho into 4 pi r square into dr. We are going to do this. Okay. Rho value is not a constant value. It has been given as a by r square into e to the power of minus 2r by a. We have to substitute that. From where to where? Our element will start. That would be a very tiny hollow sphere to the entire volume, entire bigger hollow sphere. So completely it would be from 0 to capital. These are the limits that we are going to substitute. So 0 to capital R. I'll put limits at the last. First let us do the integration. Then we'll put the limit at the last. Now we are going to see what is the value he has given for rho. A by r square. So it is 0 to r. A by r square into e to the power of minus 2r upon a into 4 pi r square into dr. Now, in this, we can remove this. 4 pi r square and r square will get cancelled out. He says a is constant. You can send it out. 4 pi is constant. You can send it out. It will become 4 pi into capital A into e to the power of minus 2r upon a dot dr. So e to the power of minus 3x or minus nx, whatever if it is there, if I integrate it, we can't integrate t, so it would be e power n minus nx only, divided by, it would be whatever value is there, it's called differentiation. Differentiation of this, it is minus 10. Okay, so we are going to use this formula and we are going to write. So e to the power of minus 2r by a ka integration would be, this 4 pi capital A would be as it is. This would be e to the power of minus 2r by a as it is, divided by minus 2 upon a. So in differentiation of this minus 2r upon a is minus 2 by a. So we're going to use that. This is my integration. Then limits are from 0 to r. Now what we do? We just 2 1s, 2 2s. So what will happen? This minus will go up. Minus 2 pi capital A. This a will also go up, small a, into e to the power of minus 2r upon a from 0 to r. Now let us substitute the limits. When I substitute the limits, minus 2 pi capital A small a, if I substitute r in this, it will become minus 2 capital R upon a minus e power 0. E power 0 is 1. So it is minus 2 pi capital A small a. This is charge. Okay, we are finding out charge. E to the power of minus 2r upon A minus 1. Okay, I hope you understood this. Now, if I multiply this minus inside, how much it would become? Q is equals to 2 pi capital A small a into e power minus 2r upon A plus 1 and minus 1 to this. That would be minus 1 minus e to the power of minus 2r upon A. This is what we are going to get. Okay, if I multiply this minus inside, this is what we are going to get. If I send this on that side, that would be q by 2 pi capital A small a is equals to 1 minus e to the power of minus 2r upon A. If I send this on that side, that would be 1 minus 1 plus q by 2 pi capital A small a is equals to minus e to the power of minus 2r upon A. If I send this minus on that side, it would become e to the power of minus 2r upon A is equals to 1 minus q by 2 pi capital A small a. This is what you're going to get. Okay, but he has given in terms of logs. So what we'll do, first we'll write what is e to the power of 2r upon A. So if I send this, what we can do, 1 by e to the power of 2r upon A is nothing but equal to 1 minus q by 2 pi capital A, because this is negative charge, so it will be this. So if I want e to the power of 2r by A, how much that would be? 1 by 1 minus q by 2 pi capital A. This is what is our e to the power of. I hope you understood this. Now we'll put logs on both sides. So whenever I put log on both sides, that is natural log. It should have been actually given as ln, but he has given it as log in the equations. So ln is equals to e to the power of ln into e to the power of 2r by A is equals to ln 1 by 1 minus q by 2 pi capital A small. So natural log of e to the base e is anyhow 1. This 2 power, this is power, so it will come in front. So 2r upon A is equals to ln 1 by 1 minus q by 2 pi into capital A small. Then we want r value. R is equals to a by 2 into ln 1 by 1 minus q by 2 pi capital A small. So this is your answer. Let us check the options. Capital R is equals to a by 2 into ln 1 by a by 2 ln 1 by 1 minus q by 2 pi small a capital. This would be our answer. The answer is fourth option. I hope you understood this. If you have any doubt, kindly comment below. Thank you.